Hi everyone, in this video we are going to continue the topic of entity transfer, which is the topic of chapter 8 of your textbook. So far what we have learned for entity transfer is that we can use some resources to perform the transfer of the entities between different stations or between different locations. And we call that a resource constraint transport. And to be able to capture that, we basically seized a resource. We perform the route, sending the entity to the next station, or using sequences to transfer the entities. And then when the entity gets to the destination, we are going to release the resource so that the resource can go and transfer other entities. The second technique that we learned was using the concept of transporters. So transporters are a type of resource as well. However, we don't define them as a resource. We define them explicitly as transporter using the transporter data menu and the advanced transfer panel. And the three main things that happens when we use transporters is that we request transporters, we perform the transport action using the concept of stations or the sequence, and then we free the transporters so that they can go and move other entities between the locations as well. So the next concept or the next technique that we're going to learn is basically how we can use conveyors to perform the transfer of the entities. So let me show you an example of how the conveyors work. Okay, consider this example. So this is basically similar to the same concept that we use for developing model 3.1 and 3.2. We have these parts that are coming to the manufacturing facility. We have 4 manufacturing cells, cell 1, cell 2, cell 3, cell 4. So these parts go on to get processed on these cells on different orders. And then when they're done, they leave the system. So here when the orders arrive or when the parts arrive, they are going to sit on this conveyor. So this conveyor goes all the way to cell 1. If the part is going to get processed on cell 1, it's going to just get directed to cell 1 right away. If not, the part is going to just continue on this conveyor. It's not going to leave the conveyor till it gets to cell 2. If the part it has to be processed on cell 2, the part is going to leave the conveyor and go get processed on cell 2, and then after that comes back to the conveyor again and goes to for example exit system area. If the part is ready to leave the system, it just gets to the exit system location and leaves the system. If it's not ready to leave the system yet, it's just going to continue on the conveyor until it gets to cell 3. If the part has to be processed on cell 3, it's going to exit to conveyor to go to cell 3 to get processed. If not, it just continues on the conveyor till it goes to till it gets to cell 4. If the part needs to get processed on cell 4, it's going to exit the conveyor to get processed on cell 4, and after that it's going to get access on the conveyor and goes back on the conveyor again, and then everything is going to be repeated. If the part still needs to go get processed somewhere in this conveyor, is going to go till the part finally gets processed on all these cells and the part is ready to exit the system. Okay, so this is one example of how these conveyors can potentially move the part between different cells till the part get processed. Okay, so what is a conveyor then? So a conveyor is composed of what we call cells of equal length that are constantly moving in one direction. Okay, so basically when we have a conveyor, like the example that we just talked about, that total length of the conveyor can be divided into some what we call as cells, and these cells have equal size, equal length. We define the size of the cells on a conveyor. So for example, if I have a conveyor of size 20 feet, I can define that I want the size of the cells of this conveyor to be 1 feet. In that scenario, this conveyor of that has the length of 20 feet is going to have 20 cells, each one of them 1 feet, or I can define the size of the cells to be, for example, 4 feet. In that scenario, that conveyor, which has 20 feet overall, will have 5 cells. Each one of the cells is 4 feet. Okay, so we define the size of the conveyor, and given the length of the conveyor, then we are going to figure out how many cells are going to fall on how many cells we can have on that conveyor. The number of cells on each conveyor must be an integer number. So we cannot have, for example, 3.5 cells on a conveyor. So the number of cells on a conveyor must be integer. We can have at most one entity in each cell. So when we define the size of the cells, we cannot have more than one entity in each cell. So at most, we can have one entity in each cell, or the cell can be empty on a conveyor. So we define that what is the size of the entity, meaning that for this entity to be carried and to be transferred on a conveyor, how many cells we need on the conveyor to be able to carry an entity. So that's what we call as entity size. So we define the entity size, and we define the entity size as the number of cells on a conveyor that are required to be able to carry the entity. And entity size must be an integer as well. So, for example, I can say that an entity size is 3 cells, meaning that it means that I need 3 consecutive cells to be able to carry an entity, but I cannot say that an entity size is 3.6 cells. That doesn't work. And then we put an entity on a conveyor when we have the required number of cells that are available, and those cells have to be consecutive cells. So when we have the required number of consecutive cells that are available on a conveyor, then we are good to put the entity on a conveyor and let it to be transferred by the conveyor. So we have to have enough number of consecutive cells that are available and that are empty. Lastly, we put an entity on a conveyor when the location of the entity is aligned with the start of an empty cell. So what does that mean? It means that, for example, if I define a cell to have a size of 6 feet, for example, and then an entity now is available, an entity gets to the conveyor and now is available to go on the conveyor. And let's say the entity should be at a specific location on a conveyor. So the entity is right at the entrance of the conveyor, that entrance location. So if one of the cells, it is at the entrance location and we are in the middle of the cell. So the entrance location is right in the middle of the cell at that time. The entity is not going to go on that cell to basically go on the conveyor. We have to wait till the start of a cell is aligned to where the entity is waiting. Then the entity can go on the conveyor and can go on that cell to be carried by the conveyor. Okay, so if at the time that an entity gets to a conveyor, that location where the entity is waiting is right in the middle of a cell, we have to wait till that cell is completely over, till that cell has completely passed the entity. And as soon as the place where the entity is available is aligned with the start of an empty cell, and we are sure that we have enough required number of consecutive empty cells to carry the entity, then that entity jumps onto the conveyor to be carried to the next location. So with these rules that we have for a conveyor, now let's go to Arena and see how we can model conveyors to transfer entities. Okay, I want you guys to please open model A2. That's the model that we did in previous week 13. So open model A2, that's the one in which we use transporters to transfer entities. So save this model as a new model in the folder for week 14. And then change the name of the model to model 84 conveyors. Model 84 dash conveyors. So the reason that after model 8.2, I jumped into 8.4 and we don't have 8.3 is that model 8.3 in your book is actually the model in which they try to simulate animations of model 8.2. So since we don't model or we don't capture the animations like I don't want to cover model 8.3, so we go direct to model 8.4 in which we show how to use conveyors to transfer entities. Okay, so save the model as model 84 dash conveyors in the folder for week 14. Press save. So now we want to see how we should change this model to be able to capture the conveyors. Okay, so conveyor. So let's go to advanced transfer panel. So conveyors, similar to transporters, are some resources. However, they have their own module to be defined. So similar to transporter, remember we went to transporter data module to define transporters. We have similar data module for conveyors. So if I want to use conveyors, I have to go to the conveyor data module to define conveyors. Okay. Before I define the conveyors, let's go to transporter and let's here delete the transporters that we have defined. And the reason that I delete the transporter is that I don't want you guys to get confused that, okay, what is used here in this model? Why do we have both transporters and the conveyor? So I want you guys to delete the transporters, okay? And if you remember, for transporters to work, we also had to define the distances between different locations. So I want you guys to go to the distance module and delete the distances that we define as well. Okay, so delete the transporter that we define and delete the distances that we define. Now let's go to the conveyor module, double click. So here we are going to define this conveyor as the loop conveyor. Okay. Since the conveyor is that we want to define in this example is like a loop, so I'm just going to name it as a loop conveyor. And don't change anything here, just let it be the default value, whatever it is. Then we have to identify the type of a conveyor, if the conveyor is accumulative or non-accumulative. Here we are going to define a non-accumulative conveyor. What is a non-accumulative? So a non-accumulative conveyor is the one in which every time we want to put an entity on a conveyor, the conveyor stops. Everything in the conveyor stops, and all the entities stop. The entity goes to on the conveyor, then conveyor starts to move, and then every time that a part wants to exit the conveyor, again the conveyor stops, and all the entities on the conveyor stop, and then that specific entity exit the conveyor, and everything on that conveyor starts moving again. However, this is not the case for the accumulating conveyor. So I will explain accumulating conveyor toward the end of this video. So for now, let's stick to the non-accumulative conveyor that I just explained to you what it is. So that's the type of the entity that we are going to model. The velocity of the entity is basically the speed of the entity that we want to be 20 feet per minute. So define the velocity as to be 20 feet. So that this conveyor is going to move with the speed of 20 feet per minute. And then the cell size. So basically it says what is the size of each cell that is defined on this conveyor. So I want the cell size to be 3 feet. This means that this conveyor is going to be composed of cells of size 3 feet. And remember I told you in the PowerPoint that then the size of the cells on each conveyor should be integer. So given the length of the conveyor, I have to define the size of the cells such that the number of cells that are going to fall. So the number of cells on that conveyor is going to be an integer. So here we have done that analysis, and I will tell you in a little bit what is the size of the conveyor, but we have done that analysis and we are sure that with picking the cell size to be 3 feet, the number of cells that are on a conveyor are going to be integer. And here it basically says maximum cells are occupied. So basically here it says that what is the number of cells that are going to be occupied by each entity. So here I'm going to pick it as 2. So in this example, for each entity to be carried on a conveyor, I need 2 consecutive available cells to be able to carry the entities. So that's basically what this number means. And if I'm going to carry entities on a conveyor, where, for example, some of the entities need 1 empty cells and some of the entities may need 2 empty cells, I put the maximum number of empty cells that are needed by the entities to be carried out here. So that's why you see max cells occupied. But here we assume all of our entities need 2 cells to be carried. So I just put the number 2. So don't change anything else here on this window, and we are going to press OK. So here we define basically a conveyor, and I call that conveyor a loop conveyor. So make sure to save before you proceed. And the other thing is that for this conveyor to work, I also have to identify the sizes. So remember, so this conveyor has a couple of cells on it, has the exit system on it, has the release order part on it. So I have to tell the simulation that what is that. So I have to tell the simulation that how these things are located on these conveyors. So this is what we call as segments of a conveyor. For example, the distance between order release and cell 1 is 1 segment in a conveyor, and then the space or the distance between cell 1 and cell 2 is another segment. The distance between cell 2 and exit system location is another segment. The distance between exit system and cell 3 is another segment, and then between cell 3 and cell 4 is another segment, and finally between cell 4 and order release. And in this diagram also you see the distance or the length of any one of these segments. For example, segment 1 between order release and cell 1 has 24 feet. The second segment between cell 1 and cell 2 has 39 feet. The third segment between cell 2 and exit system has 21 feet, and so forth. So we know the segments of this conveyor, and we know the length of each one of these segments. So for us to have this conveyor that we define to work, I also need to specify the segments on this conveyor and the size of the segments. So when here in the advanced transfer panel, if you see there is another data module called segments. So remember here for the conveyor, I told you guys when you define the name of the conveyor, I told you guys don't change this part. So this part was automatically filled when we defined the name of the conveyor. So loop conveyor dot segment. So that's the name of the segments which is defined in this data module automatically. So that's the name of the segment, this data module. And when we go to the segment, when we click on the segment, you see the loop conveyor dot segment is automatically defined. If you remember, we had similar situations with the transporter. When we define a transporter here, let me go here and just give you the example. When I define a transporter here, automatically the distance set was created for me with the same name. Okay, so that's the place, the distance set is the place where I'm going to specify the distance between different locations or between the different stations that this transporter is going to use to transfer the entity, and then distance set was automatically defined in the distance data module. We didn't define this. We didn't double click on it. It's already was defined here. We just double click on it and put the distance between all the locations and so forth. So the same situation happens for the conveyors. So for now, I'm going to delete this so that we know that we don't need a transporter or anything. So here we just define a conveyor. The segment set was already defined automatically for us. So when we go to the segment data module to define the distance between different segments on this conveyor, we see that this line, this segment set is already defined. The name has already been defined, as I said. It says, okay, what is the beginning station of this segments? So the beginning station, let's say order release. When the entities come to the system, that's where they are. That's when they begin getting going on the conveyor. So the order release is the beginning station. So order release. So we have to make sure the order release here definitely has a station. So if you don't have a station assigned to the order release, you should definitely define one station here. So that's the beginning station, and then from there the entity goes to cell 1, and there is 20, and this segment is 24 feet. So from the order release we go to cell 1 station, and that's 24 feet. And then from cell 1, we go to cell 2 station. Just go back to the graph. So from cell 1, the next segment goes to the cell 2, and that's 39 feet. Then from cell 2, we go, the next segment is the one that takes us to order exit, and that's 21 feet. So this one takes us to dispose the station, the exit part, and that's 21 feet. So I chose this for station because that's what we named this station that we put next to the exit. And then from there we go to the next segment is the one that takes us to cell 3. That is 24 feet. And from there, we go to cell 4. So the next segment is going to take us to cell 4, and that's 39 feet. And the next segment is the one that takes us back to order release again, and that's 21 feet. Okay, press OK, and make sure to save before we go further. So pay attention that here we define all these segments one after another in the same order that they exist on the actual conveyor, right? So when an entity comes to the system, even if the entity doesn't want to get processed on cell 1, the entity always goes through this segment first. If the entity doesn't want to go through cell 1, we don't exit the entity of the conveyor. We just let the entity to continue on the conveyor till it gets to cell 2. So let's assume the entity wants to get processed here. So the entity exits the conveyor here, gets processed, and then goes back to the conveyor again and continue the rest of the process. So this is the beginning station, and then the entity goes through these segments one by one. That's why I put them in the same order that we see them in this graph, and that should always be the case. So now that we define the conveyor and the segments that they are going to use, let's go to the modules and see how what are the changes that we have to make? So first, let's click on the leave cell 1 module, the one right on the right side of cell 1. Double click here. So here we have the leave from cell 1. Here, if you remember, we had used a transporter. So that's why here in the logic, I picked the request transporter. Before that, we had used seize resource. But right now, I'm going to choose access conveyor. Okay, so access conveyor. So then it tells me what is the name of the conveyor that is going to be accessed. So it's going to be the loop conveyor. And what is the number of cells that you need to be able to access this conveyor? So what is the number of cells that I need by each entity? So I need 2 cells, 2 consecutive empty cells by each entity to be able to access the conveyor. So that's the rule. And then here, in terms of the moving the parts and finally transferring the parts, for the transport, I pick the transport from the menu. For the for the resources, I picked route, and for the conveyor, I pick convey. And again, when we pick the conveyor, I can either choose the name of the next station I'm going to go to, or I can just say by sequence, look at the sequence that these entities carry and find out where that entity has to go to. So press OK, and I'm going to make that changes for the rest of the leave entities as well. So for leaving cell 2, I'm going to access a conveyor, and I'm going to pick the name of the conveyor, and this conveyor needs 2 empty cells, 2 consecutive empty cells to be able to carry an entity, and the connect time is basically is convey by sequence. So the same happens for cell 3. And cell 4. So when we are done editing the leaves module, so let's go to the enter module. So here also we had, remember we had to first release the resource or free the transporter. That's what we had here. So here in this option, so we had the option of releasing a resource or freeing a transporter. Here we are going to pick the option of exit conveyor, and here I have to pick the name of the conveyor. And that's actually the only change we want to make here. And we're going to make the same change for the rest of the enter modules for cell 2, 3, and 4. Okay, so make sure to save before we proceed. So let's go and change the other leave and enter modules that we have as well. So in this enter module, I'm going to pick this as exit conveyor again. And here in the leave data module, I'm going to access conveyor to be the one that is going to move or transfer the entities around. And the name of the conveyor is the loop conveyor, and I need 2 consecutive empty cells to be able to carry an entity. And when I'm using a conveyor, basically the action that is going to be performed is the convey. And I'm going to look at the sequences that these entities carry to find out where is the next destination. So press OK. So we are done and we are ready to run the simulation. However, before we run the simulation for 32 hours, I want you guys to go to project parameters window, and here make sure that you guys check conveyors, so we can uncheck transporters. So when we run a model that has used transporters, you have to make sure that in the project parameters you check the transporters. Okay, so when you check the transporter box here, when we run the simulation, one of the options that we see is to show us what has happened to the transporters. Here I don't use the transporters, so I'm going to uncheck. And here I'm using conveyors, so I'm going to check the conveyors. So you will see that when we run the simulation, in the report there is actually a part assigned to just reporting on the conveyors. So I'm not going to change the simulation runtime or anything. So let's just continue running the simulation for 32 hours. Okay, so this is the result. So when we click on the results, you see there is conveyor here. So we didn't have this option before. Since we checked the conveyor box on the run setup, we see the part related to the conveyor as well. So if you click on the conveyor, here we have some information, for example, related to the usage of the conveyor. So the first statistics here shows the percentage of times that this conveyor has been blocked or has been stopped. So this is percentage of the time. So this shows that this conveyor has been stopped or blocked 90%, 19% of the time. And remember, this is the non-accumulating conveyor, in which, as I said, every time we want to put an entity on the conveyor, we want to get access to the conveyor, we stop the conveyor. And every time that an entity wants to exit the conveyor to go get processed on any one of the manufacturing cells, we stop the conveyor as well. So the number here shows the percentage of the times that this conveyor has been blocked or has been stopped. And see, the maximum value is 1. So this is a number between 0 and 1. So if I just multiply it by 100, that shows the percentage of the time that this conveyor has been blocked or stopped. And the next number that we see here is utilization. And pay attention that here the utilization does not show you the percentage of the time that this conveyor has been utilized during the simulation time. That is not what this number shows. This is basically telling you the percentage of the space on the conveyor that has been used. So in this conveyor, on average, about 7% of the space on the conveyor has been used during the simulation time. And at some point, it has reached to maximum about 20% of the space of the conveyor being utilized. But on average, this conveyor, on this conveyor during the simulation time, we have used about 7.2% of the space available. So let's see how we can transform this number to getting a sense on how many cells actually have been full, or how many entities are being carried on these conveyors. So this is the space. So as I said, this is the percentage of the space of the conveyor that has been utilized. So 7%, 7.2% of the space of the conveyor has been utilized during the simulation time. So let's go back here. So if we add the size of all these segments on this conveyor, the length of the conveyor is 168 feet. Okay, so that's something that we can also find if we go to Arena, and if you look at the segment module here, on the model, if we click on the segments that we define, so those are the basically length of the segments, right? So if we add all of these, the length of all these segments is going to be 168. So here, the length of conveyor is 168 feet, and then length of cell is 3 feet. So the number of cells on this conveyor is going to be 56 cells. And then remember, we need two consecutive empty cells to be able to carry each entity. So if I divide 56 by 2, that's going to be 28. That is the number of entities that can be carried, the maximum number of entities that can be carried on this conveyor. So now, as I said, this utilization shows the percentage of the space on the conveyor that has been utilized during the simulation time, average space of the conveyor that has been utilized. So about 7% of the space of the conveyor has been utilized on average during the simulation time. So if I multiply 7% on average by 56 cells, which is available on a conveyor, that's going to be around almost 4 cells. And so that shows that on average about 4 cells on this conveyor has been utilized during the simulation time. And given the fact that we need 2 consecutive cells to carry each entity, so that shows that on average we carry about 2 entities on this conveyor. Okay, so you can also make those interpretations from these numbers as well. So let's go back to the simulation model. Okay, so one more thing that I want to mention is that if you go back to the conveyor option and you just double click on the conveyor here, remember with the in terms of the type of the conveyor, we pick non-accumulating conveyor. As I said, that's the type in which every time we want to put an item on the conveyor or an entity wants to exit the conveyor, the whole conveyor and everything on the conveyor stops. This action happens and then we move on. So however here, if I pick accumulating, so what is an accumulative conveyor? So let's assume at a specific point an entity is ready to get access to a conveyor, okay? So when this wants to happen, we stop the accumulator on that point and every point behind that entrance point. However, for those entities that are already ahead of these entering entities, they are going to continue moving, so they won't stop. But when we stop the conveyor at the entrance of the new entity, and for every other entity that is behind this entrance entity, for those conveyor is going to stop. So for those, basically the entities gradually move on the conveyor and they get close to the entrance entity. However, they are not going to pass the entering entity. They are just going to gradually accumulate on the conveyor. So the good example that helps you to get a better sense is what happens on a highway when we have an accident. When an accident happens, every car that is ahead of the accident location, they're just going to continue moving. However, at the accident location and anything before the accident location, the cars will continue coming till they get to the accident location. Then they are not going to pass the accident location. They are just going to accumulate gradually and wait at the accident location till the accident is removed, and then they are going to continue moving throughout the highway. So that's the whole concept of accumulating, and the same concept happens on a conveyor. When an entity wants to enter a conveyor, or an entity wants to exit or the conveyor, for all the entities that are ahead of that point, they're just going to continue moving. But for all other entities that are behind that point, they are going to just gradually arrive to the that point on the conveyor, and they're just going to wait and to gradually accumulate on that point till finally the entrance of the entity or the exit of the entity is over, and then they're going to continue moving on the conveyor. So here again, the velocity is 20, the cell size is 3, the maximum number of cells that we need to put one entity on a conveyor is 2, the size of the cell is 3 feet, and here it says the accumulation length. So what we define here as the accumulation length is going to allow the accumulated parts to require only 4 feet of space on the conveyor to basically wait till the entrance of the entity or the exit of the entity is over. And this value, which applies only when we have stopped and a conveyor for the entrance of the entity or exit of the entity, does not need to be an integer number. And when the blockage is over, when finally the entrance of a new entity or the exit of the entity is done on this conveyor, again, the parts or the entities will automatically respace to the 6 feet that they need, or 2 cells that they need to be able to transit on the conveyor. So basically that's what this accumulation length means here. So we can press OK, and we can run the simulation again. So when we see the result, if we look at the results again, click on the results and click on the conveyor. So since I picked accumulated conveyor, so here I have the length accumulated. So this is not similar to what we saw for unaccumulating conveyor. So here it says the length accumulated, and it's 0.9 feet. So that shows the length of the accumulation that has happened on this conveyor, and the unit is foot. So here we see that less than 1 foot space length has been used for accumulation of the entities on average during the simulation time. And then the utilization is about 5.6%. And that's again the percentage of the space utilized on the conveyor during the simulation time, average of the space utilized on the conveyor. And if we want to increase, for example, the length of the accumulated parts on this conveyor, one thing we can do is to go back on the model. Remember here for the leave and also for the enter module, we put this 0.25 minute as the time for the loading the transfer and for unloading the transfer. And here in the presence of the conveyor, this is the time that it takes for us to put the part on the conveyor, or it takes for us to remove a part from the conveyor. So if I want the accumulation length to increase, I definitely have to spend more time for putting a part on the conveyor or for removing a part from the conveyor, so that I have more and more parts accumulated during that time that I'm trying to put something on the conveyor. So let's go ahead and change that, let's say, to 4 minutes. Okay, so this is the time for putting a part on the conveyor or removing a part from the conveyor. So that's what I want to do. So let's change all of that to 4 minutes. And for I do the same as well. If I want to remove a part from the conveyor, or a part wants to exit a conveyor, I'm going to increase the delay time as well, or the time that it takes to remove a part from the conveyor, so that in that time when all the entities behind that point are going to gradually get to that point and wait and start accumulating. So I'm just going to increase that exit time a little bit. So I'm going to change it maybe to 3 minutes. So I can see the effect on the accumulation length. So I expect the accumulation length to increase from 0.9 or less than 1 feet, just because it takes more time to put a part on the conveyor or remove a part from the conveyor in this scenario. So let's press OK. So one easier way for me to change these delay times when an entity wants to gets on the conveyor or to leave a conveyor, it was for me to define two variables. Let's say one of them is the load time. I call one of them as load time and one of them as unload time. And in all these places, instead of just putting a number, I put, for example, the unload time. And also on all of these leave modules, here instead of 4, I would put load time. And then if I want to change the load time and unload time, all I need to do is to go to the variable data module and change the value of these two variables, and everything in the model would change automatically. Here, since I haven't done that, I went to every single one of these modules and changed this one by one. Here, since I don't have many modules, it's okay. But if in a model, if you want to do that, it's always better to define this load time and unload time as variables, so that if you need to change these load times and unload times to play with these numbers and to change them, you can easily just change the value of the variables, and everything in the model in terms of load time and unload time will change automatically. So let's run the simulation again. So here, if I go to the conveyor, so here you see the accumulation length now increased to about 12 or 13 feet from something around 1 feet. So that's only because I increased the time that it takes to put an entity on the conveyor or to pick up an entity from the conveyor. And during that time, during that 3-4 minutes, the entity, the conveyor stops just before the entity. For all the entities ahead of the entrance port, they are going to continue moving. But for the entities before the entrance or the exit point, those entities are gradually going to get to that entrance port or point or exit point, and they're just going to wait there and accumulate there till finally the entrance action or the exit action is done. Then all of them are going to gradually start moving as well. Again, that is very similar to what happens in terms of accidents on a highway. So basically what we learn here with the conveyor is that for the conveyors, what the actions we perform is that we access the conveyor, we convey the entities to the next destination using the stations or using the sequence, and then we exit the conveyor. So these are the actions that happen for conveyors. And just one more thing before we are done is that remember in the very simple simulation models, when we define a process, for example, the process module, and in this process module we define series, delay, release, right? And everything was fine. However, if we were in a situation when we wanted to separate these actions, the seize, delay, and release, we also had separate modules for those. We had separate modules for performing the seize, separate modules for performing the delay, and separate modules for performing the release actions if we needed to. The similar things happens for the transporters and for the conveyors. So yes, we had one module which is leave module and the enter module that led us to basically do a bunch of these things together. However, if we need to, we have separate modules for the request, for transport, and for free transporters. And also I have separate modules for getting access to a conveyor, for the convey, and for the exiting of the conveyor. So to be able to see those modules, we can go to the model again. Let's go to advanced transfer panel again. Here you see we have here, for example, for a conveyor, I have access, convey, exit. And so these are separate modules that I can put in the simulation model to explicitly happen what happens in the simulation in terms of getting hold or getting access of a conveyor, performing the convey operations, and finally leaving or exiting the conveyor. And I can do similar thing with the transporters. So here I have a request module, transport module, and finally free module. So if I need to capture what happens with the transporter explicitly, as opposed to what happens in a leave module or enter module, I can put these modules explicitly and separately on the simulation model to request a transporter to transport the entities around, and finally to free those transporters. So those are absolutely possible and can be used as well. So this is the end of basically explaining how we can use conveyors to capture the transfer of entities in the simulation model.